Uh, so the directions for this were just to factor. Okay, all you had to do was factor completely with two terms. Uh, those of you that were with me the first half, the first semester, we did this together, and if you weren't with me, you should have still done pretty much the same thing. So, what can be done first in order to factor these? What should you always look for first when you're trying to factor a polynomial? Yeah, greatest common factor, which here we have one, they're both even, so you can factor out two. Factoring out with greatest common factor is the exact opposite of distributive property. So I don't want to distribute, but if I were to distribute, I would end up with what I started with. But the directions tend to say factor completely. So you want to make sure that see, right now we have two factors. If this was the most I would do, that I could do, here's one factor, here's another one. A factor is something that you multiply. When you multiply one thing times something else to get another, the things that you're multiplying are called factors. So right now I have two factors, but I want to see if any of those factors can be factored any further. I can't do anything with the greatest common factor, that's just going to drop. But if you look on the inside, can this factor be factored anymore? What do we call that? Very good, difference of squares. And what does the difference of squares look like in factored form? Conjugates. Conjugates are two parentheses, one with a plus, one with a minus. And when the class said difference of squares, that squares meant perfect squares, meaning these two numbers here are perfect squares. I can take the square root without getting it tested. Like what times itself gives you x squared? X, so that goes first in each parenthesis. What times itself gives you 16? 4. What's available for questions because the one thing that worried me about the way that this was structured is, but maybe I don't understand. Like, hey, I got the answer, but I don't know how to put it in. Well, the way it was structured, it was a bunch of multi-select with boxes that you could check. And what you would have had to have done is found the one with the 2, the one with the x plus 4, and the one with the x minus 4, and make sure that those boxes were checked. In order to get credit for it, that's what you have to do. If not, you wouldn't have got credit for it. Show me writing all this down. Any questions there? Okay. Here we have three terms. Yeah, whether you were with me or not in the first semester, you should have worked on something like this. What do we look for first? Do these three terms have a greatest common factor? Yeah. What's the biggest number that can all be divided by? By 4. So I'm going to factor out that 4. That's the opposite of distributive property, which leaves me 3x squared minus 2x minus 8. So presently I have two factors, but I need to see if any of those factors can be factored any further. The heavy bulk of factoring revolves around this. Do you know how to factor quadratic trinomials? 3 terms. That's the big one. And then even more so than that, the hardest ones, the ones that children struggle with the most, are the trinomials where we have a lead that's greater than 1. And I'll show you why. I know a lot of other teachers in this school use this X method. Raise your hand if you know how to factor these or you've seen before how to factor these with the X. Okay. You've seen it, but you forgot it. I'm not against it. I'm not opposed to it. If you somehow feel that this is the superior method and that's the way you understand it and that's the way you're going to get it right, be my guest. That's fine. Okay. My issue with it is that I don't think it attacks what overall probably our biggest deficiency is, and that's mental math. I've asked students to try to explain this to me, like what their thought process, their logic progression is when they do this. I've asked teachers to try to explain to me how they explain this. And in every explanation I've gotten, it's still very reliant on mental math. That's what we're trying to avoid because we're not very good at mental math. So the way I do it is actually very similar. Like a lot of the principles are the same. I just structure it in a way where I think if you had to rely on a calculator, um, the calculator becomes a little more useful. Anyways, and this trinomial, the lead is 3, the middle is -2, and then we have a -8. So what I tell my students to do is start off by multiplying 8 times c. That gives me -24. I'm going to do a 2-column table. And then I put b on the top of the second column. All of my work, though, even though I have 2 columns here, I've even thought about revamping this and maybe trying to write it a different way, because really all the work is going to take place here in the left column. One of our biggest deficiencies is mental math. We are taught at an early age that, for me, it was 3rd grade. I don't know nowadays with you guys, but in 3rd grade, we learned that single-digit multiplication should be memorized. If I ask you what's 4 times 8, you shouldn't need to go to a calculator. You should be able to memorize it. Once you start going into double digits, yeah, fine, you can use a calculator. But can you come up with all the numbers that multiply to give you 24? Forget about the fact that the way the signs are configured. We can worry about that later. But what are all the numbers that you can come up with 24? If you do the X method, you're probably trying to do this in your head, and that's fine. I can do this in my head too. Like I don't have just because I'm gonna write 1 and 24, 2 and 12, 3 and 8, 4 and 6. That's just because I want to show you that there's more than one possibility. But if you can do this in your head, you don't have to write all that. Okay? Then the next thing we have to account for is the signs. We want to see how we can arrange the signs. But if you would have been with me in first semester, but I give my kids like a table and I just ask them to memorize it. Since I haven't given you a table, we can take a slightly different approach. We can try to do it this way. Okay. This is a pair of numbers, this is a pair of numbers, this is a pair of numbers, this is a pair of numbers. What all these pairs of numbers have in common is that when I multiply them, I get 24. This first column is a multiplication column. But then I want to see, number one, I have to adjust this so that I can multiply them and get -24. Because right now they just multiply to give me 24. Whatever the sign is on the second column, the bigger number of the pairs is going to have that sign. So if that 2 over there is negative, the 24 has to be negative, the 12 has to be negative, the 8 has to be negative, the 6 has to be negative. Whatever the sign on the second column is, the bigger number has to get that sign. But what I don't know is, well, do I need to also make the smaller number negative? Well, when I multiply to get a negative, what has to be true if I'm multiplying to get a negative? Yeah, one has to be positive, one has to be negative. And guess what? I already have that. I already have one positive and negative, so I don't want to change anything else. I'm going to leave it like that. The final question is, well, do any of these combinations multiply to give me negative? Sorry, not multiply. Add up to give me -2. Yeah, the 4 and the -6. 4 minus 6 is -2. If you can do that in your head, great. If you want to arrange it, as an X, I can even make this argument. If I get this table and do this, that's what it looks like an X. It's more, to me, from what I can gather, it's just a difference in the way you're arranging it. And whether how much you have to use mental math. So what you're supposed to do when you find the correct combination, which here is 4 and -6, is you're supposed to go look at the A value. Because what happens is a lot of kids just want to do this and say, oh, there's a 4 there, cool. So x plus 4, don't write this down, don't write this down, don't write this down, x minus 6. And yes, I'm supposed to drop down the greatest common factor in front of it, but there's a problem, and that's that if I try to simplify this, I'm not going to get what I started with. So what you're supposed to do is teach a method called grouping. And for years and years I did that, and the problem I kept on running into is that my higher level kids could follow it, but the other ones couldn't. So I kind of gave in and I started showing a more watered down approach, which says, okay, if my instincts tell me that you want to write x plus 4 and x minus 6, fine, go ahead. But please, pretty please, just remember this one little thing. Instead, we're not going to make it overly complicated, but you have to remember one little thing. And that's that if a is not 1, whatever the a is, you have to write it in front of the x. So instead of writing x, write 3x. But this is only temporary. This is only temporary. We're not going to leave it like that. At least one of your factors should be able to be reduced. You should be able to take out a common factor. Now, unlike we did up here with the 4, we're not going to keep it though. If we can factor it out, we're just going to throw it away. Like you would when you reduce a fraction. If I ask you what is 4 over 6, what would you tell me? 2 over 3. Like I'm not doing anything special with the 4 or the 6 or the 2 that I divided out. I'm just reducing it. Think of it as you're doing the same thing here. Look at the first factor. Can 3x and 4, do those have a common factor? Can that be divided by anything? No, so it drops. How about 3x minus 6? What can that be divided by? 3. So I'm going to go ahead and do so. Now I can't forget, I already factored out a 4. So I need to keep that. Then I'm going to keep the 3x plus 4. And then if I divide each of those by 3, I get x minus 2. Now, if I were to simplify that, I would get what I started with. If we were to go back in our time machine to Friday when we were taking this practice test, as far as the selection goes, you would have picked the box next to the 4, you would have picked the box next to the 3x plus 4, and you would have picked the box next to the x minus 2. I sent out the results again. Did anybody else other than Ann get it this time? Especially if you put your Gwinnett email. Okay. Did anybody look for it specifically and not get it? Did anybody go looking to see if I released it and then so you looked and it wasn't there? You didn't use that. I think the last school, the last school district I was at, because I've been using Google Forms for a while, I was able to, because I would just use. It wasn't. It was like the school's email, but it was a little bit different. The way it was structured was different. Where I was able to, from my school email, I was able to send it out, and everybody would get it regardless. But it looks like there's some type of restriction here, where I can only send it to Gwinnett people. So if you want this to go to you, you gotta put your Gwinnett. All right, this one, and look, these are the ones that were missed the most. Which is not saying much, because I think like the highest, I think there was one problem that was in maybe the 30% as far as correct goes, and everything else was 7%, 0%. Part of that would have to do with the fact that there were so many. I know some people didn't finish and they just rushed and guessed and stuff, but part of it is just we don't know what we're doing. This is just like the last one. There's 3 terms here. Okay. Unlike the last one, there's a 1 in front, which makes your life a lot easier. Number 1, there's no greatest common factor. So now we're just going straight into either the x, if that's what you do, or a factor chart. When a is 1, that means that when you multiply a times c, you're going to just get whatever c is, because 1 times anything is itself. If you know in your head 2 numbers that multiply to give you negative 18 and add it to negative 7, go ahead. I can do it. It's negative 9 and positive 2. It's not rocket science. So you get in where you fit in, as they say. But if you need something more methodical, Kiara, like not sleeping in class, think of all the numbers you can think of to give you 18. Remember that whatever the sign is on the second column, the bigger number is going to keep that sign, and then you decide. If I look up here for 18, in order to multiply and get a negative, do I want them both to be negative or just one of them to be negative? Just one of them. Now, do any of these add up to negative 7? Yes. 2 and negative 9. Then another big difference is because a was 1, there's no special steps at the end. I would just write y plus 2 and y minus 9. The order is not important. If you write y minus 9 first and then y plus 2, doesn't matter. It's fine. You just got to make sure the signs. You cannot put y minus 2 and y plus 9. Kiara, any questions? Another one? Just like the one we did before. Is it what? This is almost identical. Now we don't have a 1 in front. And 3 times negative 8 is still negative 24, but now it adds up to 10. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Whatever the bigger one is, that one has to have the sign that's here. So plus, 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 plus. But in order to multiply and give us a negative, one of them has to be a negative. If I know the bigger one has to be positive, well, that means the smaller one has to be negative. Do any of these add up to positive 10? Huh? Negative 2 and 12. But see, this is a perfect example that if you're not super precise when it comes to your signs and you're just trying to do things mentally, I think a lot of kids will be drawn to that because what's 6 plus 4? It's 10, but they forget that the signs have to match. Like the signs have to correspond to what it is you're looking for. Just like the one before, though, A is not 1, so I'm going to get that 3 and stick it in front. In this case, they're A's, so 3A and 3A, and then minus 2, because this is the one, that was it, minus 2, and then positive 12. At least one of the parentheses should have something in common. Sometimes they both do, but at least one of them should. In this case, the first one does not. I cannot divide 3A and 2 by anything, so it drops. But the second one can be divided by 3. Oh, by the way, I also put in the homework grades, and I adjusted the practice test grades for those of you that did the homework assignment. So you'll see that by tomorrow. If you think anything was done in error, let me know. There's a lot of moving parts. I don't think I made any mistakes because you guys are not that big of a class. But if you disagree with anything you got, let me know, and I'll explain to you how it was calculated. Now, if I were to multiply this, I get what I started with. Caleb, you writing all this down? In your brain? How are you going to feel if you end up having to take this again? How are you going to feel if you have to take this again next semester? Not good. It's better just to spend the whole period sitting there. Staring at the guy. 3 terms, but at least the lead is 1. Yeah, let's get crazy. Look, if any of you have aspirations of one day taking Algebra 2, something like this, especially where the numbers are so small, yeah, like you're expected to be able to do it in your head. I can do a chart here, but I mean, let's get crazy here. Because we have a 1 in front, we know that we're just going to start off with an A. What 2 numbers multiply to give you negative 4 and add up to 3? Positive 4 and negative 4. If you had to do a table, then do a table. Those would have been the ones you checked. There were 40 problems in total, and I don't know if I'm going to get through all of these, but there's 27 here. So that means that this was one of the worst 27 problems that were made on the 3 terms. We need to factor, but again, we have a number that's not 1 in front. So let's see, A times C here. 2 times negative 15 is negative 30. I'm going to try to speed it up a little bit so I can do a few more. The B is 1. I know it's going to be positive 6 and negative 5, but if you can't do it in your head, just use the calculator. 30 divided by 1, 30 divided by 2, 30 divided by 3, until you get all the factors of 30. You don't have to worry about the signs yet. It's not the most important thing yet. Then just try to let the rules take care of the signs for you. You know that whatever the sign is here, that sign has to be attached to the bigger one. But in order to multiply and get a negative, one of them has to be a negative, and I haven't used that negative yet, so that means that the small one has to be negative. Which one gives me 1? The one I said it would. But when I don't have a 1 in front, now I have to write 2x minus 5, 2x plus 6. At least one of the parentheses should be able to be reduced. Maybe sometimes both of them can. Here, nothing can happen to the 2x minus 5. What can I divide 2x plus 6 by? By 2. So it's giving 2x minus 5 and x plus 3. Now I'm going to start going fast with these. What's a little bit different with this one? There's still 3 terms, and there is a number that's not 1 in front, but what's a little bit different here? We saw it on one of the ones before. What do we try to do first when we factor? Greatest common factor. These can all be divided by 5 because they all end in either 5 or 0. So x squared minus 7x plus 6. If you need to do a table with the leftovers, fine. If not, let's see if we can, because the nice thing here especially is that once I brought out the 5, now there's a 1 in front. So can you think of 2 numbers that multiply to give you 6 and add up to negative 7? Yeah, negative 1 and negative 6. Whoa, Mr. Romero, I wrote negative x minus 6 and then x minus 1. That's fine. How many factors does this polynomial have? 3. So if this were the test, you would mark the checkbox next to the 5, next to x minus 1, next to x minus 6. Yeah. Well, it depends on what. Not always one positive or one negative. A is 1. Once I factored out the 5, A was 1, B is negative 7, and C is 6, right? So 1 times 6 is 6, and then B is negative 7. The numbers that multiply to give you 6 are 1 and 6, and 2 and 3. The bigger number always has to keep the sign of the second column. But now, in order to multiply and get a positive, if I know one of them has to be negative, they both have to be negative, because negative times negative is positive. So they don't always have to, they only have to one be positive and one be negative when this number is negative. If that number isn't negative, then they both have to be the same sign. This was pretty simple. I'm going to get to some equations. We can do this one here. For the second time today, there's only 2 terms. This one doesn't have a common factor like the last one did. But how can this be factored? Difference of squares. What does the word difference mean in math? Subtraction. So the question is, do I have 2 perfect? As long as I have subtraction and I have 2 perfect squares, which in this case is 3x squared and 2 squared. 3x times 3x is 9x squared. 2 times 2 is 4. Then I can just say 3x plus 2, 3x minus 2, also known as conjugates. It's all being recorded. This one. We'll do this. I want to get to some equations. The equal sign, right? This is a good one. And at least everything here is positive, so maybe we can come up with it. The number front is the 5, though. So Shobi, I'm going to have those extra steps. And when I multiply 5 times 9, I get 45, and then 18. So what 2 numbers multiply to give you 45 and add up to 18? I know it's going to be 3 and 15, but if you can't do it in your head, 1 and 45, 3 and 15, 5 and 9. Use the calculator. 45 divided by 1, 45 divided by 2, 45 divided by 3. If you get a decimal, you can't use it. The bigger number has to keep the sign of this one here, so plus, plus, plus. But then, Shobi, in order to be able to get a positive here, I can't make the last one negative because negative times positive is negative, so this would have to be positive as well. And then 1 negative 18 is here. Now, because A wasn't 1, I got to stick that 5 in front. So 5x plus 3 and 5x plus 15. I can't do anything with the 5x plus 3, so that just drops. But this can be divided by 5, which can be plus 3. How many factors does this expression have? 2. I'll come back to that if anything. That's fine. There we go. Let's get this. In total, you should have learned 4 different ways to solve a quadratic equation. There's a 5th if you use a graphing calculator, but you should have learned 4. Of those 4, 2 are used most frequently than any other. Factoring, which is what we've been working on, and quadratic formula. Okay. And I think part of the reason, not the entire reason, but part of the reason why those are the 2 most commonly used ones is because they both require the same first step. So you don't have to make the decision right away as to what method you want to use. And that first step is to make the equation equal to 0. How many terms? This is an equation now, throw equal sign. By the time we're done, you're going to have to tell me what the variable is. On all these other ones that we've done before, you didn't tell me what x is. But now you will. How many terms does this equation have? The entire equation has 3. 7x squared, 84, and the 28x. I want them all to be on the same side. I need to move them all to the same side. But if you want to still leave open the window for factoring, if you want to still say, hey, maybe I might want to factor, you should put them on the side where the a, like the number in front of x squared, stays positive. A lot of people look at this and say, well, geez, hey, there's already 2 terms on the right, so let me just do minus 7x squared to move that over there. And that's fine, but good luck factoring with that. If that's what you're going to try. It's not going to work out too well for you. So what I would advise you to do, let's do minus 84 and minus 28x to move everything over this way. I'd like to write it in standard form, so I'm going to write 7x squared first, then the minus 28x, then the negative 84. Now when we want to make our decision. Okay. There are some other, does anybody just for fun remember the other 2 methods? She mentioned factoring and quadratic formula. Does anybody remember the other methods? Square root property, but now the problem with square root property is that one only works when b is 0. So if you have any b that's not 0, you can't use square root property, but yes, that was one of them. And then there's the most evil of all. Completing the square. Completing the square. Which completing the square can be used here, but quadratic formula makes completing the square obsolete. Like, the quadratic formula comes from completing the square. It's a simplified version of completing the square. So, being that we have a limited review time, I'm not going to review all of them. That wouldn't make sense. The only way for them to really nail you, to force you to complete the square, is if they here, and I guess I can interject that. If they were to just ask you for the number that completes the square. If they ask you to solve, there really is no way for them to force you to solve one way or the other. Anything that can be done by completing the square can be done with quadratic formula. Okay? But if they were to ask you what number completes the square, okay, well, the first thing they'd probably do, because in order to complete the square, the first term has to be a perfect square. I showed my kids another trick, but most of the completing the square world does that by dividing by 8. Because if I divide anything divided by itself is no. Anything divided by itself is 1, and 1's a perfect square. So more than likely, look, right? This one, I'm not going to do it this way. I'm just trying to get it out of the way so that we don't have to go back to it. So if you were to divide everything here by 7, which coincidentally, this is what also makes factoring easier on this one. You would get, on the right side, what's 0 divided by anything? Still 0, so that side's not affected. But then over here, we get minus 4x minus 12. So if you were to complete the square, they'd have to move the 12 over to this side. Okay, you have to add 12 on both sides. So you would be saying x squared minus 4x equals 12. And then the way that you complete the square, there's two ways. When a is 1, most people, they do b over 2 squared. That's one way of completing the square. What's negative 4 divided by 2? What is negative 4 divided by 2? Negative 2. What's negative 2 squared? Positive 4. So the number 4 completes the square. Another way of doing it is saying b squared over 4a. That's the one I use the most. It's most comprehensive. Negative 4 squared is 16 divided by 4 times 1, which is 4. What's 16 divided by 4? Still 4. That's a very quick rundown of completing a square. I'm going to strategically choose to neglect that when it comes to the review. We're going to focus on the ones we use the most. So now you have to decide. Do you want to use factoring or do you want to use quadratic formula? In my experience, what I found is anytime that's not one, the kids prefer to use quadratic formula. That's fine, and there's nothing that's overly complicated about quadratic formula, but be careful because there's a lot of steps. And when there's a lot of steps, there's a lot of places to go wrong, especially when it comes to signs. I just showed you here that factoring would work because they all have a 7 in common, but I'll let you guys decide. You want to do this one factoring or quadratic formula? All right, so let's do factoring. And we trust. I'll do one quadratic formula. If you factor out a 7, that gives us that. So with the exception of the equals 0 part, we're doing everything we've done for the first 30 minutes of the class. We're doing it over again. Can you think of two numbers that multiply to give you negative 12 and add them to negative 4? Negative 6 and positive 2. I'm just trying to save time so we can do more. So I'm skipping the table. Is anybody confused as to how I got those two numbers? Then the whole reason for making it equal to 0 when you factor is because you're using something called zero product property, which says, look, right now I have this number that I do not know. I don't know what x is. I have an unknown number. And I'm getting this unknown number, and I'm subtracting 6, and I'm adding 2. But the fact is I still don't know what the number is. But what I do know is that when I multiply them, I end up with 0. And if I were to go one by one and say, Caleb, give me a number. Kiara, give me a number. Brandon, give me a number. Everybody give me a number, give me a number, give me a number, give me a number, give me a number. And without nobody telling anybody, I'd start putting it in the calculator, and multiplying them, multiply. And at the end, I hit equals, and I say, hey, by the way, guys, look, I got 0. What does that mean? That means one of you sneaky people gave me a 0 as your number. When you multiply a group of numbers, only one of them has to be 0 in order to make everything 0. So, how many factors are there on the left side? How many factors are there? Like, seriously? And you're the one that hasn't written anything today? How many factors are there on the left side? 3. But the purpose of this is to solve for a variable. So how many of those factors contain a variable? 2. So I'm going to get those factors and make them equal to 0. Plus 6 plus 6, x going to be 6, minus 2 minus 2. Because there is more than one number that makes the original equation true, you might see this written as a solution set, which they bring out these elephant ear looking things called braces. The order doesn't matter, but normally they write them from smallest number to least. Do not get this confused with ordered pairs, because it doesn't do with x comma y. It's saying that there's two numbers that make that equation up at the top true, both 6 and negative 2. Yeah, let's do this one. And this one I'll do quadratic formula just to give us practice with The good thing about, if you're gonna use factoring and quadratic formula as your two main methods, the nice thing is that the first step is the same. Jada, what was that first step that we said is the same? What's the first step that we're gonna do? On a quadratic equation. I just finished doing it on the last one. What did we say we're gonna do first? Martha, you wanna help her out? Say it better. Don't say move the thingy to the one side. Make the equation equal to 0. An equation has two sides. Make sure all the term ends up on one of the sides. And in this case, again, if I want to leave open the possibility of factoring, I would like for them to end up on the side where the lead coefficient is positive. Because if not, I can pretty much throw factoring away. And it looks, see that this one that, see that the problem with that, there's good and bad when it comes to factoring. The bad stuff when it comes to factoring is, yes, we have to be good with mental math. It always helps to be good with mental math. But really, the main bad thing about factoring is that it doesn't always work. Factoring will only work if your solutions end up being rational. I'm hoping by now you guys know the difference between a rational and irrational number. If your solutions end up being rational, then factoring should work. But if it isn't, if your numbers are irrational, or later on when you learn about imaginary numbers, if it's imaginary, you're not going to get it from factoring. But you can get it from quadratic formula. So quadratic formula is more comprehensive, but factoring, assuming that you're good with mental math, can be much more quick and solve it more quickly. And it does look like factoring would work here, but just to give you some variety, let's use quadratic formula. Let's go in the Wayback Machine. Does anybody here have quadratic formula memorized without looking at a reference sheet? Here's a memory piece. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. So by using quadratic formula, we've taken care of the solving part, because x is already by itself. All we're doing is substituting and evaluating. Everywhere you see a b, you write in this case, a 7. Everywhere you see an a, you put in a 2.